Exam Prep, India's most comprehensive preparation platform for all the engineers. All the candidates who are joining me live, just quickly confirm your presence in the comment section and tell me whether my audio, visual quality, everything is clear so that we can start with the session. Friends, today's session, the ideal duration for the session is going to be approximately 45 minutes. And the agenda for today's session is that today we are going to discuss some of the interesting questions and concepts related to your subject, electrical machines, and we are going to talk about the torque in an induction motor. In the previous sessions, we have discussed about several concepts and questions about DC machines, and today we are going to talk about induction motor, and this is going to be a very important session for you because I will not just be discussing the question parts, I will be also discussing the conceptual clarity about those questions. Is it clear, everybody? Thank you, sir. So everybody who is joining me live, just quickly like, share and subscribe the session. Just quickly like the session, share it with your friends and colleagues, and subscribe to BYJU'S Exam Prep if you have not subscribed till now, so that you do not miss any of your important faculties session. So everybody just tell me in the comment section, are you able to listen? Audio, visual, everything is clear? Everybody just confirm. Audio, visual is clear or not? Some of you may be joining me for the first time, so there is a brief introduction about myself. My name is Ashutosh. As you can see on the screen, I have 11 plus years of teaching experience, completed MTech from BYJU in 2010. I have written a couple of books, and these are my areas of expertise. Let us start with the first question. Yes, everyone. Good evening, Mr. Jayant. How are you? Welcome to the session. He is saying there is a 4-pole synchronous generator driven at 1500 RPM and it is feeding. Feeding means it is giving supply to a 6-pole induction motor which is loaded to run at a slip of 5%. What is the motor speed? Now, before we start solving this question, let me just give you a brief idea about induction motor so that you can relate to the questions, how I am going to approach them. If you see your induction motor is going to be something like this. This is how we are defining the stator. This is the stator. Stator means the stationary part of your induction motor. This stator is going to have stator windings, and they are 120-degree displaced windings. These are the distributed windings. Suppose this is phase A, this is phase B, and this is phase C. So you are giving a balanced 3-phase supply to your induction motor. It is a 3-phase balanced supply to the stator winding. And how is your stator winding? Stator winding is a 3-phase distributed winding where the spatial displacement is 120-degree between 2 phases, that is A and B, B and C, and C and A. Now we are having the rotationary part, that is the rotor. Now this rotor can have 2 types of construction, you must be knowing this. The rotor can be either a squirrel cage rotor, or it can be slip ring, or you can say wound rotor induction motor. In case of the first design, in case of the squirrel cage, there are no windings. It looks like a squirrel cage. In the earlier times, how we are keeping the squirrels in the cage. There are 2 end rings, and these 2 end rings are connected by using aluminum or copper bars. Now, just to give you a practical understanding, the squirrel cage induction motor you can find in most of the home appliances that we see people are giving in dowry. In Dahej, whatever home appliances are given, just to make it a little bit easy for you to understand. So most of your home appliances, they are working with the squirrel cage induction motor. What is the reason? The reason is the squirrel cage induction motor is very robust and rugged in construction. Whatever is going to be the environment, outside condition, its performance is going to be very good. And that is why if you see your washing machine and so many other home appliances, they are using induction motor only. Now for large size, we have slip ring or wound rotor induction motor. In case of slip ring or wound rotor induction motor, we have actual rotor windings. Is it clear for everyone? Now what is happening here, let us try to understand step by step. What you are doing, you are giving a three-phase balanced supply to stator, three-phase 120-degree distributed windings. Whenever you have this type of situation, whether it is the induction motor or whether it is the synchronous machine, you always understand when you give a three-phase balanced supply to a three-phase 120-degree displaced distributed winding, you will get a rotating magnetic field. Your rotating magnetic field is going to be something like this. This is going to be your rotating magnetic field of the stator. I hope it is clear for all of you. This rotating magnetic field is rotating at the synchronous speed. Rotating at the synchronous speed, that is ns. How we are defining ns? Ns we are defining as 120 f upon p, where f is the supply frequency coming from the supply side and p is the number of poles. Number of poles are going to be same whether it is for the stator or the rotor. That is the basic condition for any rotating machines to operate. The number of poles on the stator and the rotor windings must always be same. They cannot be different. The number of slots may be different, but number of poles has to be always same. So what you are getting a rotating magnetic field of the stator. As the name indicates, this rotating magnetic field is rotating at the synchronous speed, and definitely this rotating magnetic field is going to link with the rotor conductors or the rotor windings. Yes or no? When a time varying field, when the rotating field is going to link with the rotor conductors or rotor windings, EMF is going to be induced in the rotor windings. So what is happening? EMF induced in the rotor windings. Now very important information for all of you. For induction motor, the rotor windings are always short circuited. Rotor windings always short circuited. Always short circuited. So when the rotor windings are always short circuited, EMF induced in them, so definitely there will be some current flowing in the rotor windings or the conductor. So you will be getting rotor currents or current flowing in the rotor winding or the conductor. These rotor currents are going to give rise to their own rotating magnetic field, and that is called as rotating magnetic field of the rotor. Now the moment this rotating magnetic field of the stator interacts with the rotating magnetic field of the rotor, you get the interaction torque. This torque is the same torque that we are calling as developed torque in your motor. Everybody just tell me in the comment section, are you able to follow this or not? And if you like the concept, just quickly subscribe to BYJU'S Exam Prep, that you do not miss any of the important session. That is very important. And everybody hit the like button. Is it clear? Now what I have said, you are getting a rotating magnetic field of the rotor. Now please understand, the rotating magnetic field of the rotor is also rotating at the synchronous speed with respect to the stator. Is also rotating at the synchronous speed with respect to the stator. So we can say the relative motion between the rotating magnetic field of stator and rotor is 0. There is no relative motion, and that is the criteria because of which there can be a stable operation, motor operation, machine operation. Otherwise, a stable torque is not going to be developed. One of the important criteria for having a rotating machine is, apart from number of poles should be same on stator and rotor, that there should be no relative motion between the two fields which are interacting with each other to give you the developed or interaction torque. Is it clear for everybody? Now, because of this torque being developed, your rotor start rotating in the same direction at a speed which we are calling as rotor speed. Mr. Kumar is asking, sir, this is the attractive torque or the repulsive torque? See, this torque is the interaction torque. At the same time, it is attraction also. At the same time, it is repulsion also. Okay. Are you getting that? Let me just give you some example because you are asking this question. Suppose this is the situation. Suppose this is the situation. And suppose I am just taking a salient pole rotor like this. Okay. Or let me make it 4 number of poles. Just trying to give you some idea. Suppose this is north, this is south, this is north, and this is south. Now suppose at any point of time this is north, this is south, this is north, and this is south. Okay. Now if you see these two poles, there will be attraction. There will be attraction, yes or no? But if you see these two poles, there will be repulsion. Opposite poles, attraction, similar poles, repulsion. So in any machine you can understand the interaction torque that you are getting is not because of attraction or repulsion individually, because it is a combination of both. Actually, it is a combination of both. Prashant, are you getting this? Everybody just tell me in the comment section. Are you able to follow this? Is it clear, everybody? Now see, one more important information for your induction motor. If you see in terms of the stator frame of reference, then you have 3 speeds. First one is rotating magnetic field of the stator. So this is going to be synchronous speed. Then you have the rotating magnetic field of the rotor. This is also synchronous speed. And then you have the rotating magnetic, it is simply the speed of rotor speed. So rotor speed with respect to the stator is going to be how much? It is NR. It is NR. Now this NR is just behind the synchronous speed. The induction motor is never going to run at the synchronous speed, because the moment it runs at the synchronous speed, what will happen? What will happen? The relative motion between the rotor and the magnetic field. I am not talking about the magnetic field. Magnetic fields are already stationary with respect to each other. But the difference in speed in the rotor and the magnetic field, that slip is going to be 0. And slip is very, very important. How we define slip? We define slip as ns minus nr upon ns, and this s is actually called as per unit slip speed. Per unit slip speed, the difference between the speed in synchronous speed and the rotor speed with respect to the synchronous speed is called as slip. Whenever slip is going to be 0, the torque is also going to be 0. Is it clear? Yes, Mondal. Best wishes for you. So let us now do this question. One more important information for all of you. If you see the rotor windings is having a different frequency, that is the rotor frequency. This rotor frequency is also called as slip frequency, and this slip frequency, let me just remove this or let it be here. Rotor frequency or slip frequency is slip times the supply frequency. So let us write this, solve this question. What he is trying to say in the question, he is saying there is a synchronous generator, and this synchronous generator is giving a supply to induction motor. He is saying the number of poles in the synchronous generator are 4 poles, and it is driven at a speed of 1500 rpm. Induction motor, he is saying number of poles is 6. There are 6 poles in the induction motor, and it is running at a slip of 5%. Let us try to understand. He is asking what is the motor speed. Can you find the motor speed? Yes, it is very easy. You can simply apply the formula. NR is going to be equal to NS 1 minus S. What is the synchronous speed for this induction motor? It is going to be 120 times F upon P. What is this P? Number of poles of the induction motor. Don't confuse it with the synchronous machine. Now, number of poles, you know, number of poles are already given, but you don't know what is the supply frequency. Number of poles are mentioned as 6. So here you will be getting as 6, but you don't know what is the supply frequency. How you are going to find the supply frequency? This generator is going to decide what is the supply frequency. Just find this value of F, put it here, and this is 1 minus 0.05 because it is 5%. You can easily solve it. How to find the frequency? This frequency is going to be Pn upon 120, where number of poles are 4 for the synchronous generator. What is the speed? 1500 rpm, and this is 120. So this is coming as 50 hertz. So by God's grace you are getting 50 hertz, but directly if there is other value, then it is going to be a wrong problem, wrong answer for you. Is it clear? Just solve this. I think it is going to be 950. You must be getting B as the correct option. Is it clear for everybody? Just tell me in the comment section, are you able to follow this? Can you comment? Yes, everyone. If you don't comment in the chat box, then it is not, that it does not give me a right feedback that whether you are able to follow me or not. If you have not subscribed, subscribe the channel and just give me your feedback in the comment section. Are you able to follow me or not? Let us see the next question. Yes, he is saying a properly shunted center zero galvanometer. Now this is not going to affect your problem because we are dealing with machines. For the time being, you can ignore measurement for the time being. He is saying it is connected in the rotor circuit. So what this galvanometer is doing? Galvanometer is actually giving you the information about the frequency. Which frequency? Frequency in the rotor circuit. What is the information? It is a 6-pole 50 hertz wound rotor induction motor if the galvanometer makes 90 complete oscillations in 1 minute. So he is giving you the rotor frequency, and rotor frequency you are getting as 90 oscillations in 1 minute, that is 60 seconds. So you can solve this. 1.5 hertz is the frequency at the rotor side, and you know the rotor frequency is going to be slip frequency. So you can find what is the slip. Rotor frequency is 1.5. Supply frequency is mentioned 50 hertz. Everybody, can you just find it? What is the slip? And if you can find the slip, very easily you can write the synchronous speed. It is going to be ns, nr is equal to ns 1 minus s. What is ns? 120 f upon p, and this is 1 minus s. The frequency is mentioned as 50 hertz. Number of poles are mentioned as 6 poles. Number of poles are 6. Write it here. 1 minus, what is the slip you are getting? 1.5 upon 50. So just solve this. I think you must be getting your answer. You must be getting around 970. Is it clear? Yes, please wait. Kumar is asking, sir, speed of the rotor rotating magnetic field is equal to ns. Is it because of the stator rotating magnetic? No. Practically it is this much. See how. He is asking a very good question. He is asking how you are saying the that rotating magnetic field of the rotor is rotating at synchronous speed with respect to stator. Let us first understand. I am writing rotating magnetic field of the rotor. Okay, the speed of rotating magnetic field of the rotor with respect to rotor. With respect to rotor. Can I write it? Can I write the synchronous speed of the rotating magnetic field of the rotor with respect to rotor? Yes. It is going to be what? 120 F upon P. Now please remember, this 120 F upon P, number of poles are not going to change whether it is stator or rotor, but frequency is changing because now we are talking about rotor circuit. What is the frequency at rotor circuit? This is the slip frequency, rotor frequency. So if you write it, it is going to be 120 slip times frequency divided by P. So it is going to be slip times synchronous speed. Is it clear, everybody? What is this? This is the speed of rotating magnetic field of the rotor with respect to the rotor itself. But your rotor is not stationary. Rotor itself is rotating at nr speed. It is something like, this is a bus or train. Suppose this is a train and you are inside this train and you are moving with v1 velocity and your train itself is moving with v2 velocity. So can you tell me, for a stationary observer here, what is going to be your speed? What is going to be your speed? It is going to be v1 plus v2. Are you getting this or not? Yes or no? Train is also moving with a v2 velocity and you are running inside the train with v1 velocity. So for the stationary observer, what is your total velocity? v1 plus v2. So can I write the rotating magnetic field of the rotor, with respect to stator? So this is going to be S ns and your rotor itself is rotating. So this is going to be S ns, nr is ns 1 minus s. So this is S ns plus ns minus s ns. So this is 0. So you are getting ns. This is the reason. Okay, so mathematically you are getting that. The reason why your rotating magnetic field is rotating at the synchronous speed is because it is the basic criteria for any rotating machine. I think you have not attended my earlier sessions. What are some of the basic criteria for any rotating machine? You want me to write it down? basic criteria or principles for rotating machine. Any machine which does not obey these conditions, it cannot rotate, it cannot run, it cannot have the stable operation. Okay, Mr. Kumar, thank you. Number of pole must be same both at stator and rotor, even though number of slots may be different. Is it clear? Second condition, there should be no relative motion between stator and rotor fields. And it is very simple to remember how. Suppose I want to talk to you or you want to talk to me. So if I am running here and there, will you be able to talk to me? No. If I am stationary and you are running, so can I talk to you? No. So if we want to talk to each other, if we want to interact and if we want to develop a torque, then we have to be stationary with respect to each other. It means there should be no relative motion between you and me. The same thing you can understand here. For developing interaction torque, stable interaction torque, it is very important that there should be no relative motion between the stator and the rotor fields or flux. Third condition, the phase displacement between stator and rotor fields should not be zero. Because the interaction torque is directly proportional to sine of the angle between them. So if this angle is going to be zero, the interaction torque is also going to be zero. So always there is a phase displacement between the stator and rotor field or their axis. Is it clear? So these are some of the important principles for any rotating machine, whether it is DC machine, synchronous or induction, whatever it is. If these conditions are not met, the machine is not going to operate, whether it is generator or motor, whatever it is. So everybody, just tell me in the comment section, are you able to follow this? Is it clear? See the next question. Yes. Is it clear, everybody? Yes, Mr. Arun, how are you? Welcome to the session. Yes, everybody, just tell me in the comment section, are you able to follow this or not? Okay. Fine. Suppose this question is telling you a 3-phase 50 Hz induction motor runs at a speed of 576 RPM at full load. By what factor the rotor resistance has to be increased for the motor to run at a speed of 528 RPM? So what is happening here? Initially the speed was 576 RPM at full load. Now he is saying he is putting some external. That is so nice of you, Mr. Arun. This rotor resistance inserted in the rotor circuit, now the speed is going to be reduced to 528 RPM, but at the full load torque. It means the torque is going to remain same for both of these cases. First thing we have to understand how I am writing the torque equation in case of an induction motor. Torque I am writing as 3 times E2 naught square upon 2 pi ns upon 60. This is S R2 upon R2 square plus Sx2 naught whole square. This is the expression for your torque in the induction motor, where the symbols are going to be having their usual meaning. Now see what is happening. Generally this slip value is going to be very, very small. This slip value is going to be very, very small. If the slip value is going to be very, very small, it means R2 square plus Sx2 naught square, approximately we can write it as R2 square. If you write it as R2 square, what will happen? This value I am writing as a constant. This is a constant. If the supply voltage is not changed, E2 naught is not going to change. Yes, wait, Kumar. And synchronous speed is not going to change. Either you change number of poles or the supply frequency. So both are not changing. So we can assume this is going to be a constant. Now let us understand. We can say that torque is going to be directly proportional to slip times R2, and this is R2 square. So actually we wanted to introduce the rotor resistance. So this is going to be cancelled. So you are having torque as directly proportional to slip upon R2. Now I have to compare the two cases. First case, suppose torque is T1, slip is S1 and the rotor resistance is R21. In the second case, suppose the torque is T2 and slip is S2 and the rotor resistance is R22. Now you are saying, sir, torque is going to be same for both the cases because both are at the full load. So can I write T2 is equal to T1? So can I write S2 upon R22 is equal to S1 upon R21? So can I write R22 upon R21 is S2 upon S1? So my only job is to find the relation between slip for both the cases. Very easily you can find the slip because the rotor speed is given for both the cases. You only need to find what is the synchronous speed. Synchronous speed you can find as 120 F upon P. Supply frequency is mentioned 50 Hz, but the number of poles are not mentioned. You may face these type of questions in the examination. Don't worry if number of poles are not mentioned. You can very easily guess the number of poles for the induction motor. How? I have already told you that the rotor speed is going to be very close and just behind the synchronous speed. Yes. At full load condition, approximately it is 576 RPM. So what is the closest higher value than this? If I am going to put 120, F is 50, suppose I am going to put P is equal to 10. So this is coming as 600 RPM. Now number of poles are always going to be even in numbers. So you can put 2, 4, 6, 8, but I know it is going to be 600 RPM. So directly I am just doing hit and trial. So I am getting number of poles as 10. So it means what is going to be synchronous speed? 600 RPM. So can you tell me what is the slip for second case? Yes, 528. So it is going to be 600 minus 528 divided by 600. What is slip for the first case? 600 minus 576 divided by 600. Is it clear for everybody? Are you able to follow this? Everybody just tell me in the comment section. Very easily you can solve this. I think you must be getting as 3 is the factor by which the rotor resistance has to be increased. Similar question, the next question is little similar to this, but instead of asking you the factor, now he is giving you the value of the resistance. The rotor resistance is mentioned 0.2 ohms per phase, and now he is asking the external resistance actual value which is put in the circuit of rotor circuit per phase. Again the speed is changing from 1440 to 1300 RPM. This time number of poles mentioned, frequency mentioned, And again he is saying torque being the same as before. It means again the same torque condition you are going to follow. So directly can you write S2 upon R22 is equal to S1 upon R21. How you are finding the slip? Please see here. What is the synchronous speed? 120. Frequency is 50 Hertz. Number of poles is 4. So it is 1500 RPM. You are having the synchronous speed as 1500 RPM. Can you tell me what is the slip for the second case? Yes, 1500 minus it is 1440 divided by 1500 RPM. Slip for the first case is going to be 1500 minus it is 1300 divided by 1500. You can solve it. Now you can write R22 is going to be R21 plus R external. Just put this value here and you will be able to find the value of external resistance. Is it clear for everybody? Is it clear? So one question I am going to give you as part of your homework. Just try to do this problem and give me the answer for this question. This is a good question, very good quality question. Okay, you can solve it. This is your homework question. And tell me what is the answer to this question in the comment section. How many people are going to solve this? And give me the answer in the comment section. So this is all from my side, friends. Thank you so much for joining me live in the discussion. Take care of yourself and let us meet tomorrow when we are going to discuss another important concept for your subject electrical machines. Right now we are dealing with GATE Monsoon Free Series. Thank you so much. Stay connected. Thank you. And do not forget to subscribe. Yes. Subscribe to Byjus Exam Prep. Do not forget to subscribe to Byjus Exam Prep. Thank you so much, everyone. Take care. Thank you. Thank you.